Michael also is the other note taker, yeah. Okay, so Mike is not. So we have 3 note takers and subscribers, so we are good on that front. This is TCPM meeting. I'm Pasi. It's Michael. Yosifumi couldn't make it this time. Yeah, so note well statement, the usual stuff. If you know of IPR, you should disclose it, etc. And then I guess we can move on to the agenda. So we are going to talk about 2 working group items this time. The EDO draft. There are going to be 2 presentations, so we are presenting some slides for authors, and then Olivier is giving his analysis on EDO. This was a result of a recent discussion that we had a sort of office discussion of how do the MPTCP folks see EDO, and this was kind of a result of that sort of discussion. And then we are going to discuss about the RFC 793-BIS, which is now a working group draft. And that's also done by us because the authors are not here. Then there are a bunch of individual drafts that are shown there. I'm not going to list them now, but a bunch of new stuff actually. So most of those are 0.0 drafts. And then DCTCP is older stuff. Okay. Any comments about the agenda, by the way? Oh, and yeah, so there was also last minute addition. So we have 1 additional item in the end from Apple presenting their ECN results. So that's something that did make it to the slides, but that's a bonus presentation in the end. Any comments? And then we had maybe I give the status first, and then Gori had some announcement, but just relating to the agenda. So very quick, the status of the documents. So no recent RFCs, but soon we will have again, I think, a couple of new RFCs. So these are the documents that are past working group last call. So accurate ECN requirements is very close to being an RFC. It has been in RFC editor's queue for some time, but I think it's now finally moving forward. New consta window validation is through ISG, and there has been some edits after that, and that's submitted. So it's also going forward, I think, quite nicely. And then RTO restart was submitted to ISG just this week. And then some other working group documents. So there is this draft about undeployed TCP RFCs, and it has been on hold for a while, so we have been waiting to resolve, for ages to resolve an issue relating to how to handle the Nagel RFC and obsoleting. So I think we still are waiting, I guess. Okay, cool. And then, okay, EDO we'll be discussing soon. And then there are couple of new working group drafts that recently adopted. So RFC 793-BIS going to be the standard, and then Cubic, that is going to be an informational, just documenting the current status of Cubic implementation. And those are the working group documents. I didn't list any individual ones here, so we are going to hear about those, some of those pretty soon. And that's the status. Any comments or questions? Then, yeah, now I think Gori had some announcement.
Hi, I'm Gori speaking as TSVWG Chair. Just to let you know, we've taken a presentation on the TCP stealth draft that was discussed a little bit on the TCPM list. So we're going to have that presentation in TSVWG. So if you have comments on it, then please read it. And we'll send a note to the mailing list, and we'll do the presentation in TSVWG.
I'm not Gori. Jana Iyengar and I have a different announcement. We have a barb-off this evening on Quick, which is a new transport protocol that we've been working on at Google. And the barb-off is at 8:20 this evening in Congress 1. It conflicts with the IRTF dinner for those of you who are going there. But we will also have drinks and snacks. So.
Okay, moving on. So extended data offset option. So neither of the authors could not come here, so I'm presenting slides they made. If you have detailed questions, please do them on the mailing list. I might not be able to answer all of those. Okay, so status summary. So recently, maybe one of the most relevant updates there is that they added segment length field to optional segment length field to address the issue of middle boxes segmenting, resegmenting the packets or TCP segments, and this is intended to address that issue. Then there are some other updates on heterosis discussion about offload engines, and if you look at the bunch of like editorial modifications, so those are the recent changes. Then implementation status. Joe has had a student who has implemented this with ISI. The patch is available there, and there's also a technical report that gives some further detailed analysis of the implementation and its performance. Then I see that Joe has added my old implementation. I haven't had time to touch it for a long time, so it's outdated and it's not properly working. But if somebody is interested, you can continue. It's unlike that I would have time to continue, but somebody can carry out it once.
Yeah, is it only tested, or did you also do something like a larger measurement study on it?
No.
It was just planned?
No, realistically, I don't have, at least myself, I don't have time. But it was just, I had a spare moment at some point and started doing it, but then ran out of time.
I mean, do you know what Joe's doing there and planning on?
So I think Joe is planning to continue. I think he said that he's going to have a new student. The old student who did this part, I think he has left, but he's having someone else to continue. So that work continues. And then there is a tracebox implementation that Olivier is going to talk about shortly. And there is more about the ISI implementation. So yeah, there is basically what I said. So there is the patch available, and address is there. There's a tech report, and actually there is the information about the student and the new student. Something about the implementation here. So it supports options up to 272 bytes, and there are then some implementation issues preventing larger options at this point. I think Joe said that it's nothing very dramatic, so he believes they can address it at some point. It's not compatible with GRO, and there are some performance results without GRO EDO on, and on the other hand with GRO and EDO off. And there are more results in this technical report if you care to look at it. Okay, and then addressing the issues from Oliver's draft. So blind echo of unknown options. Authors think it should be flagged as a major bug. It could be addressed in EDO. You could add some additional data in that segments to kind of distinguish the echo thing. Authors think it's a bad idea to address in each TCP option, but yeah, it could be done if desired. And then there is a question how to react to failed segment length, this new field that was added. So if the segment length doesn't match with the actual segment length, so what to do in that case? And I guess that's an open question Joe and Wes are looking input about. So should we silently discard such segments, or should we send some sort of feedback like reset and shut down the connection or something else? And I think Oliver is having a take on this as well in his presentation. Okay, there are some more issues from Oliver's draft, and I guess the The bottom line is that the authors think that most of those are addressed already in earlier versions of the document. Yeah, feedback, welcome, needed. And yeah, as the authors are not here, and so hasn't been in recent IETFs for a while, so the request is that we will do the discussion mostly on the mailing. So of course, if you have comments now, everything is welcome, but I think it's better to take it on the list and discuss with Joe and Wes. And yeah, so there, especially about this new segment length field. So how to treat that when things don't go well. Any comments? Okay, so then we are continuing with this topic, but by different speaker. If Olivier is here. Oh no, where is Olivier? There you are. This is too wide room. It's kind of hard to reference with.
It looks strange. Can you move to the next slide? So, you want?
Oh yeah, there is this rule that people need to stand on this box.
Okay, I will stand in the box. So last week I got a question from Pasi, I think if I remember correctly. He asked me whether, as someone who knows a bit about MPTCP, whether we would accept EDO for MPTCP, because MPTCP is one of the use cases for EDO. And my short answer was no, because I don't believe that EDO, as it is currently specified, solves the problem that we are trying to solve with MPTCP. But I thought that, well, just sending a no to the list was not a correct way of explaining why I don't believe that EDO, as it is currently written, is a good solution. And I spent a few days to write a document that explains why there are issues with EDO. Can you move to the next slide? So first, I'd like to recall what is the starting point for multipass TCP. And the starting point for multipass TCP is that in multipass TCP, when we want to use multiple paths, we will do this by using different TCP options. And we always want to preserve the connectivity. So whatever happens due to the middle box interference, we want to preserve connectivity, and we want to be able to fall back to regular TCP if we detect that there is a problem with the multipass TCP options. And this has been the starting point for most of the work, for all the work in multipass TCP. And there was the study from Michio Honda and his colleagues on what are the middle box interference that exist on the internet. And this has been used as a design guidelines to design multipass TCP. And I think if we go in the direction of accepting EDO, EDO should follow these rules as well, so that whatever happens, if we start to use EDO over a TCP connection and then we detect that there is a problem with middle box interference, we should stop using EDO and continue the connectivity. Otherwise, from an operational viewpoint, it will be a mess, because you will have some TCP connection that will go through. Others will not go through because of EDO, but you do not really understand why they don't go through over EDO, and this is because of a middle box in the middle of a path that you have no way of updating and reconfiguring. So the solution that Joe proposed, just to send a reset when you detect a problem, for me it's not acceptable for the user, because the user expects that TCP will work. Next slide, please. So we analyzed qualitatively what happens when you have EDO, so the two variants of EDO that are defined in Joe's draft, with different types of middle box. So the different types of middle box interference that you have looked at are replacement of EDO with a NOP, removal of the EDO option, data injection, segment splitting, and segment coalescing, and option injection, which is unlikely, I would say, at this stage. For me, the most important one are the first one, and segment splitting and segment coalescing. If I look at the EDO option without the segment lengths, I have very bad results except for data injection. And data injection is typically what happens when you have an application level gateway that rewrites the payload for FTP. So it works well in this case, but in the other case, either you silently discard and the receiver does not really know what's happening. So in Joe's presentation, we learned that we could send a reset, so we could stop the TCP connection. This is not a good idea. And if there is splitting or coalescing, it doesn't work. Next version is the one with the segment length information. There it's better, because with the segment length information, you have a way to detect that there was some middle box interference in the network, but there is no feedback from the receiver to the sender. So if the feedback is to send a reset, then this is not acceptable for me at least. I don't want my connection to be reset because there was a middle box on the path. So if we want to go with EDO, I think we need to specify a way to send feedback from the receiver to the sender so that there is a fallback to regular TCP without EDO when there is a problem on the path, because we must want to preserve connectivity for the application. Next slide, please. So the qualitative analysis shows that as currently specified, EDO is not a good solution. There are risks with middle boxes. We need feedback from the receiver, and to convert this qualitative analysis into a quantitative analysis, what we have done with Olivier Tillmans is that we have added the support for the EDO options, so the one that you can put in the SYN packet, the one with the segment length information, and the one without the segment length information inside Tracebox. So Tracebox is a traceroute-like tool where you can send any type of packet with any type of information in the packet, and you can control the options that you send. And Tracebox will analyze the ICMP message that you receive back to compare the copy of the packet that should be found inside the ICMP message and the original packet that you have sent, so that you can detect whether there is a middle box modification. So the code is ready, and we will develop Tracebox tests so that it can be validated in the wild. And based on our experience with MPTCP, the main issues with the middle box is in the enterprise networks. So we would need help to have people that can run Tracebox inside enterprise network so that we can detect what kind of middle box interference occurs in the enterprise network. If you just use Tracebox to try all the Alexa top 1000 or 1 million, you will not see many problems because there are no middle box on the ISP networks most of the time. So middle box are either in cellular networks or in enterprise network. So that's all for me.
Okay. So thanks. And thanks. I think the draft was very nice. So it was very thorough analysis of the middle box issues, and the Tracebox work also seems very, very needed and useful. So I think this was very good stuff.
Hi, Aaron Falk. There's a research group, BOF, on Friday that is about measurement of middle boxes and how they affect transport protocols. And it seems like your interest in doing this measurement here is relevant to that. You might want to be present.
Yeah, unfortunately, I won't be there on Friday, but Tracebox is open source, and we can offer Tracebox if you want to do measurements.
And Mia Kulevin, Hubsaji chair, and there's a presentation on Tracebox from Korean on Friday.
Yeah,
so.
From Korean and Delhi, yeah.
Okay, so the main thing you see is the lack of feedback.
So there is a lack of feedback that does not allow TCP with EDO to fall back to regular TCP. Mm-hmm. And I think we need to have a better understanding on what the existing middle box will mess up with EDO before making any progress on the EDO option. So the fallback should allow a TCP connection to continue to transport data without affecting the application. If you affect the application by doing a reset, for me, this is not a solution.
So this is Michael. Do you think that this fallback is possible within the solutions that Joe presented, or are you thinking of something else as a beyond what we've seen at previous presentation?
So in multipath TCP,
for the fallback in particular.
So in multipath TCP, to manage to do the fallback, we had to put a checksum in the MPTCP option, and we have acknowledgements that allow us to understand whether there is some data that does not progress, and then we can stop doing the options. If we can get an acknowledgement, then it will be easier to do the fallback. The question is whether it's possible to do a fallback without an explicit acknowledgement for all the data or for the options. At this point, I don't know. I don't have an answer to that.
Okay. And regarding the measurement studies, so do you have a plan? Is it likely that you will have some initial data, say, in the next IETF meeting, or?
So the plan is to develop the tests, and once the tests are ready, we have modified Tracebox so that it collects all the packets and send them to a server so that we can analyze them. And the issue will have to have people to run it. So Tracebox is running on Linux and on macOS. And it's a user space application. You have to be root, but it's a user space application that allows to test. And we have a way to implement an EDO server, compliant server, so that you can test all the interactions with the server.
Okay, I would suggest that once the tool is ready, please send an email to the TCPM mailing list, so that this is really encouraging.
I will do that.
So Michael will present the slides for RFC 793 for WES.
Yeah, so I'm obviously not WES, but I'll try to give an update on what happened since the last IETF with 793 bis. And as these slides have been prepared by WES, so I'll give my best to present what I understand on it. But obviously, as if there are any detailed comment going to the list, or you will see later, there's another way to contribute here, is obviously also a very good idea. So in general, we adapted this in the last meeting. And we also added a milestone to the TCPM charter. It's pretty way out in 2017, simply because we know that this will be a difficult and challenging working group item. It's an internet standard, and it will require review. But still, we hope that we can at least meet this milestone target. There's now the working group version of the draft in the data tracker, and you can see as usual the differences between the version. The most you will see on one of the next slides what has happened since the last version, but the main new text that was submitted recently is on the segmentation issues. And as Wes has already worked with the individual versions, he plans to submit incremental updates of this, mostly addressing one specific issue or a small set of issues, so that it's easy for the working group to track the changes and also to review them. One of the most important next steps is to fully incorporate the 1122 changes in addition. So I think Wes already did this partially, but there's still things pending. And in general, what's very useful is in the document, there is in section 4, there's a list of items, and it's at the moment a relatively long list. And obviously, this gives an overview of all the pending issues that are still to be done in this document. We had some discussion as chairs with Wes on how we can facilitate contribution from the working group, and we decided to start an experiment. So that's something that we've not done in TCPM so far, but it's already done in other working groups. And Wes also agreed to this, and so we'll do the experiment. So for this document, the XML source is available in the Git repository. So if you are willing to review something, you can retrieve it there, and this obviously might also facilitate the work of Wes when integrating patches. So we are really interested in figuring out whether that simplifies contribution. But obviously, we have to follow here, for this particular document, in any case, the IETF's consensus process. And keep in mind, this is an internet standard. So any changes obviously have to be discussed on the mailing list. So we're not planning to reuse Git here as a replacement of the consensus building process, but we are experimenting here whether that simplifies, for example, the submission of editorial changes. And also, we hope that it simplifies keeping track of changes, in particular, since in this document, any change is very, very important to review. So if you're willing to look at this, if you're willing to test this, so please try it out, and also feedback from the working group, whether that's an interesting way to pursue in future, would be very welcome. Then regarding the current status, so Wes has incorporated a couple of errata on sequence number validation. He updated the text on urgent pointers. And he also updated the sequence number generator. So these are relatively straightforward changes because we have a standard track RFC that updates RFC 793 already. And then regarding diff, the most important new thing that was added is probably the segmentation section, whereas clarified the MSS calculation. He added some text on path MTU discovery, something on Nagel algorithm, and also something on jumbogram support. And this is this changed quite a bit of lines in the RFC, so it's relatively important that you start reviewing this. I think it's better to review things early than if you then in 2 or 3 years have a full review process of all the document, and that this will be relatively challenging to handle. So please look at these changes. Please give us feedback. Please comment on the mailing list. Any feedback here would really be welcome. So then there are a couple of things that we like to have feedback from the working group, because Wes is not able to do this completely alone. We need input from the working group. And we have 2 questions here on this slide and the next slide to ask. So the first question is on the scope. When we adopted the document, we obviously made clear that any change here will require a very strong and explicit consensus in the working group. But there are some, and in particular, we will try to narrow any changes to things that have been specified in standard track RFCs already. However, there are a couple of corner cases where it's not exactly clear whether some well-known modifications of 793 should be incorporated in 793 BIS or not. And Wes has listed here 3 examples. The first one is there is a well-known variation of the Nagel algorithm, which is probably in some variant implemented in the Linux kernel. I think as far as I recall it, it's about reducing the interaction between Nagel and the delayed act timer. And it's never got into the standards track series, but it's probably, at least as far as I understand it, it's probably not a bad idea. But since it's not formal part of the standards process, we are a little bit struggling whether something like this could be in scope of 793 BIS or not. Then I think that definitely will require discussion, in my opinion, is what we do with the reserved bits. I think in 2 years ago or so, we had a lengthy discussion about what it exactly implies that these bits must be 0, because this is what 793 tells. And as far as I recall the discussion, this is a nightmare for any future use of these reserved bits. So we probably have to discuss whether we can change this, and if so, how we can change it. And any thoughts on this also would be very welcome. In particular on that one, also on the mailing list. And last but not least, we have another example, what was already discussed quite a bit in this working group, but we never really reached a clear consensus. And that's the sequence number validation in some corner cases. We have Fernando's draft that tries to fix this, but it didn't get a lot of traction recently. We didn't receive a lot of feedback either. And anyway, on that part, we would also really look for feedback. We would also in particular look for feedback from implementers telling how the problems that are known with the sequence number validation are actually tackled in implementations, because we know that these issues are addressed in implementations, but we really look for feedback from implementers.
Okay, so as an implementer, we said some feedback, I don't know, 1.5 years ago. Should I resend that then?
I think it would be good to restart this discussion. I also think Fernando's not very active on that draft, as far as I understand it. So if somebody else is willing to look into this, we could also think of that. Or at least you could start a discussion with Fernando, or I don't know.
But I was more I don't think I have the cycles to do anything about this, but I can resend the comments that I gave, or if the comments somehow are stored, I don't have to resend them.
you can resend them. Maybe this helps at least to trigger this discussion. But the former problem that we have is at the moment we don't see a lot of energy in the working group to address this, even if it's a well-known issue. And now we have to decide that, or at some point in time we have to decide what to do with this. And in particular, the last thing is also a cycle issue, obviously.
Gordon, at the risk of digging up things we've already dealt with, but the description of checking the reserved bits must be 0. Wasn't that in the BCP published saying that it was normal behavior, like they should be set to 0 on transmission and they must be ignored on reception? There's a BCP that actually says that as a correction to 793.
Okay, I don't recall.
If that helps with the standards process, if that's what we want to do, it has been out in the wild for quite a while.
Okay, I don't recall that one. I know that it was discussed, but I don't recall that BCP. So,
how do we deal with the status of this document at the end? Are we keeping that in mind? Is it going to be full international standard, or?
It will be a full internet standard, in my opinion. So we discussed this, I think, also with the AD, and I think an update, in obsolescence of an internet standard is an internet standard. So that's at least my understanding.
Okay, then the group needs to be aware of this through these edits.
Yeah, but the group has to be aware that this document, once it will be published, has probably the status of internet standard. And this is why we are so careful with any changes that are not specified on standards track. So in any case, also what we've written here on this slide clearly applies. So we haven't made any decision what we do in that space. It's very clear that every change that's not in a standards track RFC already, we will have to have a very explicit consensus on that. We will probably very individually call that out on the mailing list. But we basically look for feedback here, for thoughts from the community, whether in very specific and selected cases we add such things or whether we strictly limit the RFC to what has been specified in the standards track series. And any thoughts on this would be really welcome. It's a procedural question, actually, but obviously we have the issues here and we somehow at some point in time have to come to a conclusion. We don't have to do this, we don't have to decide this today because we have many meetings to discuss this document in future, but please think about this, and if you have thoughts, or if you have thoughts on these things or other things, then please comment, and in particular also comment on the mailing list.
Mia Kulevin, I think I'm very much in favor of documenting in this document what's deployed wide scale in the worldwide. Would it be an option to say in the draft that this was added newly because it's deployed in the scenarios? Maybe that helps to distinguish what the status is.
Yeah, the chairs had a discussion a little bit in that direction, whether to add, for example, an appendix or something like this that non-normatively describes certain deviations that are very widely deployed but not part of the standards track series. That would be one way, for example, to deal with it.
Aaron Falk. It's very desirable to have consistency across the RFC series in sort of what the meaning of the different levels of standards are. And so I would suggest that maybe you want to ask your area director to consult the IESG to get some guidance from them. Perhaps this kind of thing has come up in other areas. I think that there may not be sort of the right breadth of expertise about the standards process sort of in this room. I think that as far as sort of making the distinctions technically on what to include and what not, that's where that expertise lies here. And then another point is I would be, I don't think that there's any way that you could take something that wasn't already standard in, say, must. Right? I think that that's the kind of thing that you would have to do the full standards process in IETF less column less stuff.
Yeah, but the challenge is 793 doesn't have a lot of musts in there, so it doesn't have a lot of normative language.
Makes it easier, not harder. I'm talking about the new stuff.
And Gary first, just so that people know, 6man is trying to do the IPv6 spec rev at this moment, so the IESG will be thinking about this sort of thing probably before we get to it.
As representing a group that implements TCP, I would really think that it's very unfortunate if we end up with a draft that, or an RFC that specifies what is there because it was there in some previous RFCs. And then in the appendix, we have some features that basically we could all agree on we want to have, but they don't go into the RFC just because they weren't there before, right? I think that's very unfortunate. So I would support that we do try, I mean, these examples to get a consensus and then have them either in or out.
Okay, thanks. We will feedback that also to Wes, obviously. And then we have another question that's maybe a little bit simpler to discuss because it's a very specific question. So Wes is thinking about whether at the end of the document there should be a table explicitly specifying all normative statements, because something like this was done in 1122. And he's basically looking for feedback if the working group thinks that this would be a good idea or not. And also if you have any comments on this, any thoughts, then please feel free to speak up either now or post this to the mailing list. So I see that obviously nobody here has any opinion on that. So I guess in that case, Wes will probably do whatever he believes is best.
Jana, that seems like a good idea. But I'd probably have to see the whole thing to figure out if it actually makes sense, because this can become very big.
Yeah, it can become big. That's true.
Yeah, Kulevin, I'm not sure if it's actually helpful, because if you want to implement it, you have to read the text anyway, but it probably doesn't hurt. It doesn't hurt to have it, sorry.
I know that our implementators love this.
Such a table would be great if it's accurate. So you might want to call for volunteers to proofread this table and make sure.
Yeah, we have already called out for volunteers for proofreading the whole document. So that table is actually simpler than some of the other things.
Well, my just thought is that it would be very tedious to proofread this table. Mm-hmm.
Okay, and regarding the next steps, so obviously this is really work in progress. There are a lot of things that have to be added. So Wes has just mentioned some of the steps here that are on his short-term roadmap, a couple of RFCs that will have to be added. Also, we already discussed in the past, the scope of the document is that it will obviously not include the congestion control, not include timestamps and what is done in 7323. But there will be references to these documents, and this will to be added. And anyway, as I mentioned before, there's a long list of to-do items which are still pending, and Wes will go through them, but obviously, this document would really benefit from feedback. So if you have any cycles to read it, to read the changes and review the changes that Wes already met, so please help the working group with feedback and post to the mailing list or play with the new Git infrastructure.
Yeah, Kulevin, again, very quick question. Wouldn't it be sufficient to have a pointer to the roadmap?
I guess the roadmap, that there will be a pointer to that one, but the roadmap is not normative. So because I think the way how it's currently phrased in the document is that this is not a complete specification of all things that you have to do for having a fully standards compatible TCP implement. It's only specifying the data format basically. And that's why the roadmap alone is probably not sufficient. But I'm not sure whether the roadmap is already referenced there, but I guess it will be in there because it makes a lot of sense as an informative reference. Okay, if there are no further comments, then I guess we'll move on. And I think we are at the end of the working group items, so we then have the data center TCP presentation. And by the way, has anybody not signed the blue sheets? Because I saw some late arrivals.
Good afternoon, Praveen Balasubramanian from Microsoft. Today here to talk about Microsoft's data center TCP. This draft was presented earlier in IETF 89 by Lars. There was a bunch of discussion on the mailing list. Today we are going to discuss, I'm mainly here to discuss the updates to the draft. And one important thing before we move on, I want to point out that there's an IPR disclosure. Microsoft has granted a royalty-free license for other implementations. We can go ahead. To quickly recap DC-TCP, I'm not going to go into too much technical detail. It's a variation on the TCP congestion control algorithm for deploying improving TCP behavior in a data center environment. If you notice in the data center, the type of flows that we normally see are short flows that have very strict SLAs. For example, query processing for a search engine, and then there are really long flows, background flows, which are like storage traffic, live migration. The goals are to provide really low latency for the short flows and also ensure that we can minimize loss as much as possible and also provide high throughput for these long-running flows. The approach, the key idea in DC-TCP is to take the single bit feedback of ECN and make it a multi-bit feedback so the sender can actually determine, the TCP sender can determine the extent of congestion rather than just the presence. So it changes it from a loss semantic more towards exactly determining how much congestion I experienced in a particular round and tailoring the C-wind such that I can minimize loss and coexist well with other DC-TCP flows. So the C-wind is not reduced by half, which is what the RFC 3168 proposes. So this is a change where in every round, the receiver acknowledges every congestion experience marked from the router, and the sender can determine exactly what proportion of packets were marked and then reduce C-wind proportionally. Go ahead. This slide is from the previous presentation. So this was kind of the state of the art in terms of known DC-TCP implementations back then, which was the original implementations in Windows Server 2012. There was a free BSD implementation, and I believe there was also a Linux kernel patch. Next slide, please. So there's been a lot going on since then. There's a lot of momentum behind DC-TCP. Most notably, there's a new Linux kernel patch which has been signed off by David Miller, so it's kind of an official patch. The newer versions of Windows Server 2012 R2, as well as the new one that's slated to come out next year, continue to support DC-TCP. It's actually enabled by default, so Windows servers actually, all outgoing TCP connections negotiate ECN by default. And if the RTT is less than 10 milliseconds and ECN is successfully negotiated, then connections are automatically data center TCP. Now, if the network doesn't do ECN marking, like the switching or routing fabric doesn't support ECN, then this degrades to new Reno. Apart from other implementations, there have been more deployments, most notably at Morgan Stanley. There was a Usenix paper by Glenn Judd, who's now a co-author on this draft, which described their experience with deploying DC-TCP in the data center and all the related benefits. So there has been independent verification that DC-TCP does provide the documented benefits in a data center environment. This is also under evaluation of other groups at Microsoft, like Microsoft Azure. NetApp is also evaluating it. Academia, there have been citations to the DC-TCP paper recently. And at IETF, there has been the accurate ECN proposal, as well as the dual queue coupled AQM proposal by Bob. Both of these kind of borrow the key idea from DC-TCP, which is to use the multi-bit feedback of ECN.
Yeah, Kulevin, I just want to clarify that the accurate ECN idea comes from Connex or ECN, which was earlier work from Bob.
Sure. Yeah. Fair enough. So yeah, this primarily shows us that there is a lot of momentum here, and people are very interested in DC-TCP. Next slide, please. I'll briefly talk about what has happened since revision 0, which was when this was initially presented. We've improved the draft for both completeness as well as clarity. So there was feedback on the mailing list. We have tried to address most of that feedback. I'll go over the key ones here. The original draft did not talk about SYN reset and PURAC packet handling. So RFC 3168 forbids TCP implementations from marking these packets as ECN capable, which is the ECT setting. So the original implementation in Windows Server did mark these packets. It's just that we did not document it in the RFC. This ensures that switches that have set AQM for DC TCP traffic do not drop these packets and cause new flow establishment to get penalized. The other point that I want to bring up is the coexistence with conventional TCP. Assuming that the deployment is uniform and everybody is talking DC TCP, then this problem doesn't exist. But if your data center has a mix of traffic which is non-TCP or even like conventional TCP, then those traffic can get penalized. So one of the proposals in the Morgan Stanley paper was that you use differentiated services to segregate these traffics on the switches so that they occupy different portions of the buffer, and you could do like drop tail for the conventional traffic, and you could do AQM for DC TCP. So we addressed this in the deployment issues section. We also enhanced the implementation issues section, which is changes other than congestion control for making TCP work well in the data center, which is lower timeouts. So for example, min RTO and delayed act timeouts, which are traditionally very large values, can be lowered to around like 10, 20 milliseconds, which is what Windows Server does. The other thing that we propose is that C-Wind restart be implemented, because the traffic conditions in data center for these short flows can change very rapidly. We are starting to address loss handling. This is not completely addressed in the draft. The current implementation in Windows degrades to new Reno when there is loss. We also don't reset the congestion estimate value, which is alpha. The Linux kernel implementation actually provides a knob to reset alpha when there is a loss episode, and we do mention that as an implementation issue. We also, yes, go ahead.
You said C-Wind restart. What did you mean by that?
After an idle period, like an RTO, you want to restart your C-Wind to like 4 or 10 or whatever is the default in the operating system.
Follow-up question. Do you have any data on whether this has helped?
We don't have published results on this, but based on experimentation, this seemed to help because you do have these bursts of flows. So all these map-reduced workloads, you have bursts from these senders of short flows, and you do not want to start them off at whatever the higher value that they had reached in their previous computation. So
are these connections paced or are they not paced?
No, these connections are not paced.
Okay. It'd be great to have some results from that, because my intuition is actually quite different on this, and it's entirely possible that the data is going to destroy my intuition. But yeah, it'd be wonderful if we had some data on that. If you have a recommendation in here, it'd be useful to have some data if you could bring it to the group at least.
Sure, we can probably try to see if we can come up with some data. Right now, we don't have that data, but. Yeah, so by default, Windows Server will use a lower min RTO, a lower delayed act timeout, enable C-Wind restart, and also do data center TCP by default for these low RTT flows.
Thanks.
We also addressed all the feedback from TCPM mailing list, mainly it was editorial and improving the clarity of the text. This is an ongoing effort. We would appreciate any other feedback that you have. We will make sure that we address it in the next revision, and we plan to do a next revision in the next couple of weeks. So any feedback there would be appreciated. From our point of view, we think this draft is near completion. I think we have pretty much addressed most of the main glaring issues in the draft. We are open to other suggestions in terms of what can get this to completion. We are open to working with TCPM. So we really want to accelerate these deployments because for example, today we can do this in Bing, but to deploy this in an IaaS-like scenario where Azure is there, there's a mix of operating systems. So we really want there to be like really good interop. So publishing this as a draft information RFC would certainly help. So we request TCPM to consider publishing this as an informational draft.
Okay, Laura, so let's first have a discussion about any of the content that was presented.
Okay, so Gary, first, just on the thing here, when you negotiate data center TCP, you do it based on delay.
So we don't negotiate data center TCP. So the sender and receiver arrive at the conclusion independently. So there's no explicit negotiation in the SYN. As long as ECN is successfully negotiated in both directions and the latency is less than 10 milliseconds, Windows Server will automatically try to do data center TCP.
Okay, so two things. First one is by setting ECN on the SYNs, you stand the chance that the ECN might be black-holed and therefore the SYNs might. Do you have a way of retransmitting the SYN if it's not, or do you just rely on timeouts?
The SYN retransmission. So we attempt ECN negotiation on the first two SYN packets. On the second retransmit, we stop negotiating. So if it's being
which could be quite long if you have an internet RTT. This could be like 5 seconds or something. If you have a long path.
That's correct, but this is intended for being deployed in the data center, and the latency condition kind of protects us, because if you're doing large RTT, then we don't do data center TCP.
I was kind of hoping you'd say that, because the second one is the draft doesn't seem to say anything about deployment in constrained environments where you actually control the boundaries and therefore you know exactly how far this is going to go. Can that be put in the abstract?
It's not in the abstract, it is in the introduction. So we do mention that this is recommended to be deployed in the data center environment where it's a single administrative domain.
I'd hope it was stronger in the abstract, saying it should not be deployed outside of it.
We can certainly consider that feedback, yeah. Thank you.
So Richard Scheffenegger, NetApp. I have a follow-up question again to this negotiations. You mentioned you have the three-way handshake, and when the latency is less than 10 milliseconds. So you know it on the sender side. So I'm curious how you figure this out on the receiver side.
Yeah, so
the receiver also change what is reflected and how it's reflecting, right?
Yeah, so since it's a three-way handshake, there's a one-way delay measurement on both sender and receiver, at least for the SYN packet. So the assumption is that in a data center, actually, we see the latency is actually sub-millisecond. So 10 milliseconds is like a large enough buffer for us to be able to make sure that both sender and receiver arrive at the same conclusion independently.
Which opens a corner case when the third packet, the ACK, is delayed. So that basically in one direction you have a measurement that is below, and in the other direction you have a measurement that is above.
That is possible, but in our data center, yeah, sure, that's a known problem. Yeah.
Well, Briscoe, I mean, you have the other problem where one it hasn't implemented it and the other has, and that's a sort of more major problem. Just a procedural question. Sorry, Bob Briscoe, did I say that? Do you intend this informational draft to sort of freeze your description of TCP as you've done at some point, even though you're likely to evolve it beyond that?
I think from this draft's point of view and the Windows implementation of DCTCP point of view, we are kind of close to completion. So we don't think there are any outstanding issues in the implementation. This is successfully deployed. Even Morgan Stanley has deployed it as documented in the draft. So and seen good results. So I think this is pretty close to done.
But if there is evolution, like TCP itself has been evolving for years, you plan to do what?
Yeah, but just a comment here. So we have in our chart the possibility to document algorithms as they are deployed. And this means that we document it at a certain stage.
That's what I'm trying to get the answer out. You know?
And the same is for Cubic. I mean, yeah. Cubic also will evolve after we've published the RFC.
This is a frozen sort of, this is how it was at the time.
Yeah.
So Dave Taylor. So I think on the previous slide where it talked about how if you had data center TCP on some machines, not other machines, and Morgan Stanley talked about how you might use different queues or whatever. I think what's important now is to say there's a particular snapshot of data center TCP that can be deployed on all these implementations that can work well together in a data center. Okay. Now, as future evolution happens, that just means that now you have to worry about what happens if some of them use the RFC version and some of them use a future version, just like right now we have to worry about what if some of them use DCTCP and some of them don't. Okay? So it's just another of the same considerations that would happen in a future version. It says, okay, and how do you interoperate? Is it something that is a natural evolution where they coexist perfectly fine, or is it something where you have to use, say, different queues or something like in here? And those are the sort of considerations we need to worry about in the future. But I think right now, the same reason that you're worried about is actually the reason to get this thing to an RFC sooner than later so that you can verify that these implementations work well together, right? And now we'll have something stable to point to.
Joanna Kulik, Google. I used to work on the crawl team, which was our biggest consumer of MapReduce and storage. And now I'm on the networks team. And so my question is related, which is, if we wanted to play with this or experiment with various aspects of this in a data center with one of our bigger apps, do we need, what's your experience? How does it play well with existing TCP? Does the whole data center need to move up to TCP, or are they fair, or are we going to now crush other apps?
This would actually not coexist with other TCP or other
So we
traffic.
need to bring up, if we're going to play with it, we need to bring up the whole thing.
You either bring up the entire cluster to do DC-TCP, or you basically do what Morgan Stanley suggested, which was use differentiated services to handle this traffic differently in your switches and routers.
Bob Briscoe, and in answer to that, hello? In answer to that, in answer to your question, we in AQM yesterday, we also showed another way to do that with an AQM that Alcatel Lucent has developed, which you might want to go and have a look at. And there was a barb-off yesterday where we have now asked the ADs if we can start a new mailing list called TCP Prague at IETF.org to develop DC-TCP and evolve it so that it can coexist with other traffic. Okay. And I was going to ask my own question, but I can't remember what it was.
Okay, actually, that's
I know. Yeah, I know. It wasn't a question. It was a point about negotiation in the accurate ECN thing that's just about to go to RFC. It's just coming out of RFC editor.
I'm cutting the lines afterwards for the technical questions.
We have suggested that negotiation of accurate feedback would be an implicit negotiation of the main thing that you're doing differently is giving a different meaning to the feedback, and that would sort of imply that you're possibly using DC-TCP. Yeah.
Sure. Yeah.
Hi, Aaron Falk. I have not been tracking this protocol, but I'm just, I guess, a procedural question. Are you bringing this to the IETF and handing it over to be an IETF protocol and giving the IETF change control, or are you trying to document something that you're doing and just letting the TCPM community know what it is?
We are documenting the current implementation. The goal, since there is a royalty-free license, we would like other implementations to adopt this because we think there is clear benefits in the data center. And in an IaaS-like scenario where there's a mix of OSs, we would like that to be like a good interop so that we can get customer workloads to get the benefits out of DC-TCP. So that's kind of the goal here, and that's why we want to.
So this is a Microsoft protocol?
This is intended to reflect the Microsoft implementation of this protocol, yes.
Okay, then I will probably do an adoption call, but as a first I'd like to call out explicitly some procedural things that we discussed as chair. The first thing that I want to remind is that we already did an adoption call of this document, the mailing list, a couple of months ago, and the feedback on that adoption call was relatively weak. We got a few replies for people willing to review. And our conclusion was that this is not sufficient in a TCP working group for such a substantial, not necessarily minor modification of TCP. So for us as chairs, in order to be willing to adapt this, if there is a positive feedback from the community, the feedback must be much stronger than what we've seen on the mailing list before. So that's very clear on our end. This is just a heads up.
Andrew McGregor. But given that this is an informational documentation of something that exists independent of the IETF, should not the barrier be much, much lower than for something that is being adopted by the working group to work on as an IETF recommendation? In other words, the barrier for implementation, for informational documenting something is much lower.
That's well understood, but I think we got something like 3 emails back or something like this, and that was not a lot. No. I'm not. Actually, I think I'm not accepting comments on that one here, so we will do the hum anyway. So then. Okay then.
That was really easy, Michael. Jana Iyengar, I just wanted to say that as there's work that's going forward, or people are actively working on items that are based on DC-TCP and are going to be affecting internet environments, it's very important and useful to have an informational RFC that actually documents exactly what DC-TCP does. This has been a problem for things like Cubic in the past. It has been a problem with pretty much everything else. It seems extremely silly to not have as information RFC something that may have significant impact on what the internet looks like in the future. So, just a point. Thanks.
Okay.
Mia Kulevin,
Be quick.
I want to apologize. I missed the last call. I replied afterwards. In the meantime, I did a review. I think actually it's a very well written document. It's an informal RFC. I think like 3 views is definitely enough because it's in very well shaped, and I think we're ready to move forward.
Sorry, first, I'm worried about the use of loss as a signal in it. But apart from that, I think we should document this informational, move forward, and design a better protocol here if we can do.
Brian Trammell, I would be deeply skeptical if publishing this as an informational document for a thing that has already been implemented and deployed would be harmful to the internet. And that should be the barrier, so I'm in favor.
Lars Egger is one of the co-authors, so there wasn't a lot of strong support when we did the adoption call. However, we actually got more private feedback from various implementers and working group participants directly to us that says, hey, I read this, can you fix this? Than I have gotten for other things that went standards track here.
If the working group doesn't want to work on this, I would fully support publishing it as an independent submission RFC. But if the working group doesn't want to spend time on it, the working group shouldn't spend time on it, and you should publish it, and you should go do something else.
Yeah, okay, that's well understood, independence. And then there's a second thing that we discussed as chairs, where I also would like to get feedback also from the authors. So it's about the title of the document. We already had this comment earlier. At the moment, the document is titled Microsoft's Data Center TCP. That's something that's a little bit unusual in TCPM. So I'm willing to hear feedback on that one.
Lars Egger, again, as an author. So the first version didn't have Microsoft in it, and we added it because there's sort of a tradition in the IETF that if you document something that isn't an IETF document, you're putting the name of the company or something into the title. So I think there's a lot of, Cisco's and Junipers and whatever's genitive protocol. We don't care what the title is. So if you want to take it out, take it out.
No, I want to have feedback on that one because in TCPM we have a certain tradition not to do this for working group documents. So,
Dave Taylor, I was going to say the same thing as Lars, but since I have a Microsoft affiliation, I can say we don't care whether Microsoft is in front of it or not. And the first version didn't. We did not expect to put it there. We put it there in response to other feedback because we didn't object to having it there, but we didn't want it there to begin with. And so whatever the working group asks for is perfectly fine with us. It's already multiple implementations right now that are interoperable, and we just want it to be an RFC and don't care whether it's listed as Microsoft or something else. So.
Yeah, Kulevin. So I think it's okay to have Microsoft there because in informational draft, we could go for an individual submission, but we discussed it already enough in this working group that this would be the fastest way forward, I think, and then we should just go for it.
No, they want to be explicit. For an individual stream submission, the company name is fine, but we are asking about if it becomes a working group item, if the working group has any preference whether it's in there or not. And I also want to recall the other protocols that were developed by certain communities where we decided not to put a company name in the title.
Both is fine.
Same here. I don't have a strong opinion as to whether Microsoft's name appears in it or not. I would like to see if there is, to ask you to test the group to see if there's sufficient commitment to do a working group last call review of the document before committing to take it on. Because it sounds like that's all you're going to do. You're going to take it on, you're going to last call it, and then you're going to publish it. And I would say the words publish as an RFC and fast do not belong together. And that, and there's actually no value from it, right? The speed to getting something out as an RC, is small, and I think that the more limited resource rather than time is working group cycles, and so that's the thing to focus on.
Jana Iyengar, you asked for feedback on the name.
On the title.
On the title.
Assuming that we adapt it.
Yeah, my suggestion would be let's get rid of Microsoft so we can avoid this silly debate altogether.
Or Gary, if we remove the name, then this causes other problems.
Okay,
so we just need to go through this.
Okay, I will do a hum on the name afterwards.
If we're going to bike shut, so my thought was that, well, I came to the microphone with the thought, if we're going to bike shed the title, we should fully bike shed it. and I actually have, I think, I have a serious point to make along these lines, which is, I thought it seemed to me wrong to call it Microsoft's data center TCP, or because data center TCP is a much bigger deal than just Microsoft, as big as Microsoft is, because it's so useful in so many applications. And I actually, when I came to understand what data center TCP was and how useful it was, I was disappointed that it's called data center TCP, because I think that's very misleading to people who might be looking at it trying to figure out whether they should read it and understand it, because it's useful in far more than just a data center. And it would be nice to find a better name for it.
Yeah, okay, we will not find another name here.
I know, because everybody knows that it's...
I'm adding the lines here.
I would be in favor of taking Microsoft out.
Okay.
Yeah, Kulevin, very quick. That would be a different document, Tim.
Yeah.
Liza, so I think so I don't like the name particularly either, the data center name, because of what Tim just said, right? However, that's what it's known under, and changing it now confuses the hell out of everybody. However, the next one, in some sense, right? That's why the mailing list that Bob mentioned is called TCP Prague, because we couldn't come up with a better name than data center TCP yesterday, but we didn't want to pick one, so we were just picking some tag, which is TCP Prague, and that's gonna have a better name, I hope. But this one I would like to keep as data center TCP because everybody understands what it is.
Okay. I will ask 4 questions. So the first one is, could you please give him a show of hands who has read a recent version of this document? So this is, let's say, more than 10, probably 15. And then a very crucial question: who would be willing to review the document for clarity and whether it sufficiently is understandable? I think it's clear here that we will not change the protocol, but we need people that look for it whether it's clear. So I see amongst other Richard, Lars, Jana, Gori. Yeah, okay. We have more than 5, so that's good. Then I will do a call for a hum on working group adoption. So as usual, I will first ask for a hum if you think that the TCPM should adopt this document as an informational RFC. So if you think that this is a good idea, then please hum now. So for the minutes, this was a relatively strong hum. So if you think that TCPM should not adopt this document right now, then please hum now. So for the minutes, there was no hum. And then the last question about the title. So I will offer 2 options. One, we keep, the first option is we keep the title as it has been spelled out in the most recent version with the company name Microsoft on it. So if you think that this document should have the start with Microsoft, then please hum now. So this was a weak hum. And if you think that the company name should be removed from the document, meaning that it's mainly called Data Center TCP, then please hum now. So for the minutes, the latter option was significantly stronger. So I think the conclusion is we will adopt this document as Data Center TCP heading for informational.
No, I just want to ask, Bob Briscoe, I just want to ask what that still means that this is about Microsoft thing, it's not just not in the title. Yes?
It's not in the title, no. So as usual, I mean, we will not remove the server's implementation things. It's not just not in the title. Okay, then thanks a lot. We sorted it out, so we'll move on. Thank you. So then Richard is next.
Or Alex.
Alex, sorry.
Yeah, so this is a new draft. Basically, it's a short presentation for a short draft. It came in our mind after or during the meeting in Hawaii when Bob presented inner space, and this was a part of the inner space was an idea that we can reply or that we send TCP in an option, and we get a reply from the receiver, and then we can have in mind, okay, this would be a good idea to have a general option because we have more cases than this case where we can have simply a ping pong. So next slide. Exactly. So we have a couple of use cases when a TCP sender would like that some data simply echo back from the TCP receiver. For example, a TCP timestamp option, or when we have maybe in future another semantic with another timestamp, this simply when we would like to get some data back, or the SYN flooding protection that I mentioned already, or for example retransition ambiguity detection, what Richard will present afterward. So we have a couple of use cases where we would like simply that the receiver echo back some data. And so this draft is somehow we rewrite the idea from RFC 1072. So this is should be in common denominator of all these ideas above that we would like to have. And what it's different to the original idea is, first we have a little bit different semantics, and the second thing is we have a variable length option. So our data, we can go to the next slide. You can directly see that our data in our echo option is variable, so we can put any data there. Yeah, so the idea is quite simple. So we have during the three-way handshake, we initiate this option. It's basically the same how the Edo does his exchange. And another point is discuss a lot if you would like to allow that we have this option multiple times in option space, and we thought that this would be not a good idea because then we have a couple of cases we need to cover. For example, with delay egg, what we do, and or we have losses, and then we need to store the data and like this, and then in which order we send back the option, or we can avoid if you only or we only allow that we have this option one time in the option space. And if you would like to use this option for different meanings, then simply decode it in a data field. So it's up then, let's say, to the application how we encode it. So our point was it is enough to have this option only one time in the option field. And then last thing is that the semantics to the original idea is a little bit changed because we apply with the most recently received echo option. That means when we have, for example, delay egg, we have it's possible that we receive this option multiple times. And so here we would like only to reply the most recently option. Yeah, so basically that's it for Page's draft. So we got a little bit feedback on the mailing list from Parse and Yushun. Maybe other guys have other ideas, other use cases. We can use this option. And for us, the next steps would be to incorporate this feedback. And if we have enough positive feedback, then eventually we would like to ask for another option, but maybe not today.
Jana Inga, given that we have the timestamp option, what are the use cases do you have for something like this?
Yeah. So one use case would be the SYN cookie stuff. Yeah. So you did what Bob proposed. Yeah. Another idea is this spurious retransmission detection. So currently it's based on timestamps and it's only deployable in Linux, but we have different operating systems.
What detection?
The Eiffel detection algorithm.
Ah.
This is based on timestamps, yeah, but it's only deployed on Linux, but we have different operating systems, Apple, or all this BSD stuff, yeah, that is not deployed. And actually we burn a lot of space with the timestamps option. Yeah, we can do it much shorter. Yeah. I read an email that Richard posted. It was also new that might have also an idea that that we can use a pause based on this, that we don't need the timestamp anymore. And last but not least, this was also a point from Mark Orman that the whole RTT measurement is not better when we have timestamp enabled. So this was his point. So, and if you can get rid of, so the last thing I see personally, we need timestamp with spurious retransmission detection. When we could do it in a more clever, better, and shorter way, we can get rid of timestamps, and we have we can have more option space available. Not 35.
I don't see the value of getting rid of the timestamp option if you're just going to replace it with this. I can't see you're going to save any bytes, because you'll have in order to achieve pause, you would have to carry this in every packet.
Yes, and this will be my talk.
Okay, you're agreeing. Okay.
Yeah, we split these two talks because it's two different drafts. Yeah, here we don't speak about so much about the use cases. It was only the wire. Maybe
the motivation use case for this, as I understood it, was Bob's inner space options stuff. I thought
this would be one use case.
Yeah.
Right.
So, but there are many possible use cases. I think that's your strongest argument. But there are many possible use cases.
Right. Maybe we can go further to the next presentation. Then we mix the discussion.
Yeah, then anyways, regarding the procedure here, that draft alone doesn't make a lot of sense. It comes along with use cases, so that's why the thinking in the working group is, also if we adopt this at some point, we will probably not adopt it alone, but together with at least one or two use cases of it. So that's why we look forward to further thinking from the working group how this could be leveraged and how the corresponding use cases would look like. And once there's agreement, there's a promising use case, then we would probably start discussing how to exactly scope the documents and so on. So that's why, I think, in my view, also it makes sense to discuss this together with use cases.
Jana, I agree with that. I think I was just talking to Matt, and it seems like the way you want to collapse which one gets echoed in ACTS back will depend on the use case that you have.
Yes, correct. So the main difference from timestamps is really in the semantics. Timestamps reflect back the last in-sequence data, whatever it is, basically.
Right.
And the echo option reflects back the most recently received, whatever it was, regardless of the ordering in which it was received. And both of these have value. And using them together. So we're not proposing to get rid of timestamps completely and forever. So for RTT measurement, for example, well, the semantics of timestamp is what you want to have. For other use cases, and I believe the list of use cases which require the modified semantics of the echo option far outweighed the use case of the semantics for timestamps, actually, if you think about it.
Yeah, no, it certainly seems like a very, very nice bit of feedback to have. It's something that we don't have right now.
Yes, and so perhaps you can start up, Mike.
Yeah, unless Matt wants to comment on this specific draft.
So did you think about other encodings in particular, the way you have it set up, if you want to do it symmetrically, you need to use two options all the time. One could, for instance, require that the data be even and do the same option half-length splitting that the current algorithms use.
That's why we're proposing we are basically not yet in a fully fleshed out phase, and getting that feedback is very valuable. And if you think that condensing some of these instead of having one option in one direction, the other option as a reply, and one for
if you made the rule length had to be even, you could use the same option.
And sometimes you want that, and sometimes you don't want that. So that's why we have split it into two different documents, because one is just the signaling. This was Alexander's Now basically I'm presenting one of the use cases that we've figured out. Some of you may have known me working on this with timestamp negotiation before we updated 1323. Next slide, please. So one of the uses of timestamps right now is Eiffel detection. So Eiffel detection, a short summary, is basically when you run into a retransmission timeout and you're retransmitting a packet, you want to know if that retransmission was spurious because of the heavy cost for the retransmission after retransmission timeout incurs to the TCP session. So if it was spurious, you can rewind all these changes to the state of the sender's TCP session, TCP machine, and continue with the session as it was before. However, as Eiffel runs using timestamps, it is limited because of the semantics of timestamps. These semantics impose the limit that first, typically timestamps are run on a clock and not on a count or something. Therefore, if the time granularity is too short, you don't have a signal at all. The second thing is it doesn't work for any reordering event or any other packet but the first retransmission. So if you have multiple retransmissions in a window, which may overlap, or if they're just reordered, Eiffel detection doesn't work. And the basic idea is, as Matt has pointed out, to tag every single segment with a very short, unique field, which makes it uniquely identifiable. This doesn't mean that the echo option needs to be unique per packet. And then the sender can figure out not only which packet has arrived at the receiver, but also the ordering of these packets. Next slide, please. So from an architectural point of view, we have a counter, which is monotonically increasing for simplicity. And this counter only needs to be a very small value. So a single byte actually suffices for this particular use case. And you only increase this counter whenever you enter a loss recovery. Whenever the whenever the TCP sender is not in loss recovery, it doesn't change its state, it's continuously sending, the same value will be transmitted over and over again, which makes it very easily compatible with things like TSO. And on the receive, on the reception of an ACK, you check, the sender checks this option and compares it if it's the current value of the counter or if it is a previous value of a counter. And depending on this, you can figure out if it was a spurious retransmission or if it was a valid retransmission. There are some other things like you shouldn't be rewinding, you shouldn't react to spurious retransmission, obviously, when in your retransmission window, at least one of the retransmissions was valid, obviously. But it's also, all of this is written in this draft. Next slide, please. So this is basically some, I'll go quickly through this. That's interesting. That's quite interesting. Okay, so anyway, so this should be showing just the first use case, the first thing, that basically with the granularity of the timestamp is not fine enough. Eiffel doesn't have a signal on which to work at. Whereas if you have an implementation architecture that runs out of a counter, the counter can be increased whenever, independent of time, and therefore you always have a signal. Next slide, please. Yeah, I thought this would be the case. So here we basically have the very the Eiffel detection case. So we have a spurious retransmission over there, and we have two acknowledgements, one for the initial one and one for the retransmission one. And Eiffel in this case can, since the timestamp has not rolled over, cannot detect that the retransmission was spurious, other than perhaps counting the X. Next slide, please. Yeah, even more worrisome, especially when the green circle doesn't describe anything.
But this was messed up by the IETF toolchain. It's not the chair's fault, neither the order's one.
Thank you very much. I didn't want to put you on the spot. So basically, what the echo option with the changed semantics can do, which the timestamps option will never be able to do because of the changed semantics, is to address some of the more obscure corner cases, you may say. So basically, we are approaching the perfect solution with this, I would say. In this case, we have basically reordering of two segments which are reordered in between as well, which is a classic case which Eiffel would not be able to detect. With the echo option, which basically makes it very clear in which order all of these packets arrived, the sender can figure out that all of the retransmissions, both of them, were spurious, and can then react accordingly. Next slide, please. And another thing, we don't yet have a draft on this, is lost retransmission detection. So this is another thing that happens rather often, particularly in data centers when they are not using AQM. I may point out that the retransmission gets sent while there's still a congestion event going on, and the retransmission is lost in this congestion event as well. And TCP has then a very hard time, at least standardized TCP, to recover from this event, and it has to go, revert to a retransmission timeout. Using the echo option, again, this event can be detected without any ambiguity, and we can retransmit a lost retransmission in a fast way, rather than waiting for a timeout and everything that goes with it. Next slide, please. So overall, Alex has pointed this out. The echo option itself allows to use a much smaller overhead because we are not stuck with this symmetric way where we have to have a fixed field in both directions. We completely solve the retransmission ambiguity problem, and therefore all of the goodness that comes from this can be addressed. And Jana,
I think I really like very much the fact that we're able to get away from the retransmission ambiguity if we use something like this. At the same time, it's not fully clear to me. I think I had to spend some time thinking about it. But how do you? So the echo happens only on the packet only on one packet, right? So there's an echo and the echo reply.
There's no state in the receiver.
Okay, so the echo reply is immediate and it's
so if there's a delayed ACK or something,
that's fine. But
then the data in that data segment, the echo data that was in the data segments that you not ACKed to is lost.
Oh. Okay. Yeah, I'll have to think about this. So it's not clear to me how you can get away from loss of ACKs, problems with loss of ACKs and things like that.
I'm not saying that the signal is perfect, but it gives you a differentiated signal to what
completely seems to suggest it's perfect.
Yes, so of course.
Okay.
There are always corner cases, right?
Ian Sweat. To clarify, I think what we're getting at, I think, and I'm trying to think through this, that as long as you strictly follow the standard TCP rules for delayed ACKs, I think it ends up being shockingly close to perfect.
Yes.
And it's
provided there's no ACK loss.
Yes. But the reality is that a lot of people violate those rules egregiously, either intentionally or unintentionally. And so that's kind of where the
please read the draft. For this particular use case, we thought about this problem, and we thought about how to basically make the signal good enough to address the spurious retransmission detection, provided that during the retransmission events, when you're in reordered state on the receiver, when you don't have lost X at that point in time, you get all the signals that you need.
Yep, I agree. It's certainly an improvement.
And during loss recovery, we don't have delay X.
Yes.
And I was about to close the lines, but I guess I don't need it.
Okay, so anyway, as what I'm seeing here, there's a certain interest in this, but I also think people want to think about this. I have one formal thing here. As a chair, I'm obliged to follow the note well. And in this particular case, this is related to the Eiffel algorithm, which means that it's RFC 3522. And what you will see is in the next couple of days, or maybe today, I made a third-party IPR disclosure because the Eiffel RFC has a known IPR disclosure. Obviously I cannot tell on the applicability of that IPR, but since that mechanism seems closely related to this, the working group has to be aware that there might be IPR on this from a third party. So if you see that IPR disclosure on me, I have to do this since I'm aware as chair that there is another RFC in, I think in TSVWG that standardized the IPR algorithm. It has nothing to do with my own work. It's not my own IPR.
Last second, so I think you're over-interpreting the rules. So only if you, because it's not your IPR, you're only obliged to this. So you're asked to disclose if you personally know or think that that applies. But you just said you haven't looked at the patent, so you can't know.
I have looked at the patent.
You have looked at the patent. Okay, thank you.
Finally, I want to point out that the draft actually includes something like 15 different use cases, 15 different scenarios that will work out in the expected way, some of which extend beyond what Eiffel can do, and it's never worse than Eiffel, of course.
Can you be quick?
So it sounds like a very good idea. The question is like, how much overhead do you have compared to the performance you gain? And that's a question you might want to answer in future. You don't have to answer it yet. But also the question is because the echo option, that's probably further more common for the echo option, is a very generic thing. So the receiver does not understand what's the inside of the echo option. So the receiver might not have an incentive to support the echo option because it doesn't know what the echo option is used for and if that's actually only overhead or if there is a performance gain in it to support it.
Jenna, is it okay if we continue the discussion? Go.
Very quick comment on that. I came over a little late from my chair. Just want to say, I mean, I know SCTP comments are not always so welcome here, but for your information, we have actually made room in the SCTP chunk header, made a new chunk header with exactly the purpose of making room for a corresponding echo option in SCTP with and we'll have a draft that has expired that will come as a new draft, the next IETF, where we'll intend to use this kind of option for the same purposes as you do here.
Thank you. Jana, do you want to point out the quick stuff or?
Very quick.
Well, just to answer what Maria asked, it's actually being able to eliminate retransmission ambiguity, and I don't think that this fully does it, and I need to think about this more. But it's actually hugely simplifies reasoning about any loss recovery mechanism that we work on. It allows you to do things like recovering from losses of retransmissions and so on. And so it's a problem that's worth solving if we can.
Thanks.
Thank you.
We move to the next presentation, which is fast open extension for IPv6 prefixes.
So good afternoon, everyone. So I'm Mohammed Hawari. I'm currently an intern at Cisco Systems. I'm going to talk to you about TCP fast open for IPv6 prefixes instead of IPv6 addresses. Next slide, please. So a few words about the motivation and the context for this extension. So I'm currently working on a research project about an IPv6-centric distributed storage system. So basically, we're trying to emulate a hard drive by mapping each LBA of the drive to an IPv6 address. And so we have a bunch of servers, and we are routing to each one of them an IPv6 prefix. And this IPv6 prefix corresponds to a certain storage space. So each time the client wants to access a particular block, it sends a request to this address, and it's routed to the server that contains the actual data. Next slide, please. So we have to create a TCP connection for each new request because the endpoint for TCP connection is an IPv6 address, not a prefix. So according to our measurement, we noticed that the achievable throughput of this disk is very sensitive to the RTT. And after some profiling, we realized it was due to the three-way handshake, the initial three-way handshake of the connection establishment. So as we're facing very transactional traffic, we decided to use TCP fast open. Next slide, please. So the problem we had is that a TFO cookie is only valid for one IPv6 address. So basically, if you have a prefix and you access different addresses within the same prefix, even if it's managed by the same entity or by the same server, you have to ask for a TFO cookie each time, and you lose all the benefits of using TFO basically. So the idea we had is to extend the domain of validity of TCP fast open, or the TCP fast open cookie, to include the whole prefix. This way, the client can reuse it for further transaction within the same prefix. And the applicability of this extension. So we have mainly 2 points. The first one consists in assigning an IPv6 prefix to a whole prefix to a server instead of a single address, and having the benefits of TFO. And the other one is to have a cluster of servers within the same prefix that can use the same cookie for all the transactions. Next slide, please. So we propose a solution in a draft. Basically, it consists in creating a new, in specifying a new TCP fast open option length, new TCP option that contains the prefix length in bits for which the TCP fast open cookie is valid. So basically, when the server will deliver a new TFO cookie, it will include this option to notify the client for which prefix it can reuse this TFO cookie. Next slide, please. So this solution addresses the problem and is completely backward compatible, but I mean, there are many discussion points. The first one was raised by Yoshong on the mailing list. Is it worthwhile enough to burn a new TCP option for this, for such a small thing? I mean, the TCP option space is quite limited. And perhaps we could think of another solution. I mean, letting the application decide for which prefix length a TFO cookie is valid. That would require the current implementation of TFO expose a new API for the application or anything else. And I want to start a discussion about this topic. So, do you have any comment or questions about it?
Andrew McGregor. I'm not sure. I mean, I think your motivating example is a kind of amazing hack, but not something I quite buy.
we call it research.
Of course. It certainly sounds like a heap of fun. However, the actual feature, assigning a prefix to a server or perhaps any kind of VIP or something of the sort, and being able to make TFO work for the whole prefix, I think there's value in that. I don't have an opinion about the mechanism for achieving it, but the goal seems reasonable.
Thank you.
Hey, Charlie Pauly, Apple. Just maybe one idea for how you could not burn up an option for this. It'd be interesting to see if maybe you had some limit to essentially the subnet prefix that you could share a cookie between, and if you had a previous cookie from anywhere within that,
just try it.
If you don't know, just try it, because it doesn't hurt, and you just try the most specific cookie you have for that prefix length. That may essentially get the
that might be a possibility. Yeah. How would you fix this limit?
That's why you define it in a standard.
Okay.
It could be fairly large.
Yeah.
Right.
Okay, so I guess we take any further comments on this to the list. As allocating an option number is not a low-hanging fruit in TCPM, so we would need a lot stronger interest in further pursuing this. Thanks a lot.
Thank you.
That's fine. alternative backup with ECN. Short draft, not so short presentation, I guess.
I'm not sure if the presentation will be as short as the draft. Okay, I have to stand in the box. Okay, so this is going to be about the TCP alternative backup with ECN. I have to mention that this has been partially funded by the RIGHT European project. Next slide, please. So basically, what's the story? We have the latency problem in the internet. We're trying to solve that with the standard TCP. What's the problem? The standard TCP has a multiplication decrease factor. We call it beta from now on in this presentation, which is equal to 0.5. So which means that it goes half every time it sees a loss or an ECN mark. That means in order to get more throughput, you need to do buffering more. So the more throughput you need, you do more buffering. That means more latency. And if you want with a single TCP flow, standard TCP flow, you need at least a BDP of buffering in order to get the full utilization. So that's the problem. There's a solution for that, and that's the active queue management. So we have a lot of active queue managements recently being worked on in the AQM working group. They all try to keep the latency at a very low threshold. So like FQ Codel, Pi, Adaptive Red, and so on and so forth. So if you look at these state-of-the-art AQM mechanisms that have been proposed to solve the buffer bloat problem, we see that most of them, they actually keep a static certain threshold, which generally corresponds to having a tiny average buffer. Of course, they absorb bursts and so on. But basically, on the average, it looks like as if you have a tiny average buffer, which is in order of 5 to 20 milliseconds for Codel and Pi. So in the plot, as you see, the lower curve, that's actually the standard TCP. So in order to get the full utilization, you need to have a buffer size that is equal to a BDP. And then if you have a higher beta values, then you actually get a better utilization at the low thresholds. This is with Droptail. So next slide, please. So we're trying to use AQMs. What is the problem with that? With those AQMs? When you have long RTT paths, most of these AQMs they bring the link underutilized. So if the default threshold is the way it is right now, which is in order of 5 to 20 milliseconds, then if your RTT has above 60 to 80 milliseconds using our experiments, we saw that actually the link goes underutilized. That's because the AQMs actually are going to drop or mark the packets within one RTT, and basically they're going to make the flows go underutilized, and as you see in the plots. So with Codel and Pi, so when the RTT is short, it utilizes the link fully. When the RTT increases, then the link goes underutilized. Next slide, please. So in order to solve that with a large RTT path, what we can do, we can increase the beta, of course. But what is the problem with that? So, and as an example, like cubic. So the red line corresponds to a cubic flow. Both of these uses a beta 0.7 by default, a beta that is larger than the standard. The one that is the red color lines, they use a Q length that is a half a BDP, and the one that is in blue color uses a 1 BDP buffering. So if you're just using a higher beta, what is going to happen is that you're going to actually create standing queues if you're using large queues, which is quite common on the internet. So next slide, please. So packet loss is not a clear indication. If you see a packet loss, it's not a clear indication that this is actually showing us an onset of congestion. So it could be a tail loss. It could be coming from an AQM. So we are not sure about what is the source of packet loss. But when we see an ECN-CE signal that is explicitly telling us there is an AQM on the path somewhere. So that explicit knowledge so far is not being utilized by the TCP protocol. What is happening so far is that the TCP reacts to the ECN mark the same way as it reacts to the loss. So if we see a CE mark in the future, it's most likely to be from Codel or Pi or similar AQMs that keeps a low marking thresholds. So what we can do with that, we can actually update the TCP's beta only for ECN to a larger value and still get a good utilization. So we propose the alternative backup with ECN. We call it APE. it's only a simple TCP parameter change. That parameter change is to use a higher beta than 0.5 with response to CE mark, but also reacts to loss the same way as in the standard with 0.5. It's only a few lines of code in the kernel, and it's only in the sender. Next slide, please. So this is with one single flow with Codel. As we see, the upper stack of the plots is the improvement over the beta 0.5 in terms of throughput, and the lower stack of plots is the queuing delay, the CDF of the queuing delay for different beta values. So if you look at the lower one, we see that actually this Codel AQM is able to maintain the latency, the maximum latency, or the CDF 100% around the target delay. And what is differing between different beta values is only the lower part of the CDF, which is below the 100%, which is below the target delay. And if you look at the upper part, we see that using a higher beta, you actually get better improvement over beta 0.5 in percentages. I'm not going to go into the net values of those percentages. But what we can see is that when we have the x-axis in the time scale from 0 to 300, then actually in the beginning of the connections, you see more benefits in the large RTT paths. And then as we go forward, we also have some improvements. Next slide, please. That was with Codel. This is with Pi, the same situation. Pi and Codel both are able to keep the latency low and also provide improvements when in the beginning of the transfer, you actually get more benefits in most cases. Next slide, please. So what can happen here is we have two stacks of plots again. This is with Codel, and we've got an RTT on the left side, and we have the throughput on the right side. So with regards to the RTT, we changed the beta from for different RTT values from 40 milliseconds to 200 milliseconds, and from the beta 0.5 to beta 0.8. And we use APE in this example. And then with the throughput, we also have the same setting. So what we can see is that as we change the RTT to larger values, the Codel and Pi, the Codel is able to maintain the median RTT basically almost constant for all the cases. But so with different beta values, but the throughput actually improves when we increase the beta. Whereas the RTT is not going to get suffered by increasing the beta. So in that way, we are able to actually maintain the latency low for all the settings in there. But as you see in the boxes on the right sides, then we can maintain a good throughput level. So basically, you can have the cake and eat it too, which means you can have the low latency and high utilization. Next slide, please. So there are some issues with using a higher beta value with ECN. First is the TCP's convergence time. So we look at the different, these are all real-life experiments. We look at the different set of bandwidths and different RTTs. So we looked at the mix of this with different beta values. And so the plots on the left and right, they show Pi and Codel with different beta ECN values. And then we compared the TCP's convergence time for different beta values against the default beta ECN 0.5. As we can see, using different beta values is not significantly worse than using the beta ECN. Sometimes the convergence is better, sometimes the convergence is worse. And as we can see, the middle point is around 0.5. Which means that basically using a different beta value is almost approximately neutral to the choice of the beta, because sometimes it's better, sometimes it's worse. Next slide. So another issue that we had to look at is the friendliness with the standard TCP, with the standard loss-based TCP if you're competing against it. So of course, if you're using a higher beta value, it's going to push the standard TCP away. And then we plotted this for different settings of number of flows when there is one non-ECM flow versus 9 in one side of the spectrum, and another side of the spectrum is 9 no ECN flows versus 1 ECN flow. And then we can look at the fairness with pi and caudal for different beta values in that range of spectrum. As we can see, of course, with the extremely large betas like 0.9, the fairness is going to be not so good. It's like the ECN flow is going to get like 2.5 times more than the standard TCP. But if we choose a reasonable beta value, which is like around 0.8, then we can almost approximately go around 1.5 to 2. And keep in mind that fairness, in a strict sense of fairness, is not so important. This, of course, in some cases you may really care about fairness. In that case, you can use FQ caudal or mechanisms like that. But in this case, we think that convergence and fairness are really hard to quantify, or it's not like so sacred. So we can have some compromises over that. Next slide, please. So with regard to the short flows, nowadays the page, the web page sizes are increasing in size. So what's going to happen is that most of the web page sizes, there's a chance that they end up being the transfer ends right after the slow start and not during the slow start. So this is trying to look at what is the benefit of using a higher beta value right after the slow start when you have a CE mark. So there is a benefit of that by using that. It reduces the page load time of large web pages. Why it does that? Look at the example. So we have got two examples together. They are not related to each other, but we just put them in front of each other so that we can compare them. So one example, the red line is basically the lucky line, and the blue line is the unlucky line. So these are TCP trying to go to slow start in the beginning. And what happens is that right after the last part of the slow start, the red line overshots by a lot. And then it reduces by half. And then by reducing by half, it ends up being just below the capacity line. So, but in the case of the blue line, which is capacity line is in the lower dashed line, it just overshots. It just overshots by little, and then it goes half. And what happens is that it takes a long time for the blue line to ramp up to the available capacity. So that is right after the slow start. So it's just a matter of how lucky you are during the end of the slow start, or where the 0.5 puts you in this at the end of the slow start. But if you're using, so if you're using a higher beta value, what's going to happen? The chances that you're going to be basically end up being right at the capacity line or above it, and then reduce in a step functions, then is higher that you actually can utilize the capacity better. And the step function in there, of course, it induces a little bit of latency, but it's an order of log of 0.5 to the base of the beta ECN, so it's a limited number. Yep.
Yeah, Kulevin. So what's the buffer size in this simulation?
So the buffer size here is, this is an AQM, I guess. So I have to look at the paper. I'm not quite sure what is the maximum buffer size. But I think it's a BDP by default within our.
It's a low marking threshold. It's a low marking threshold.
Yes, yes.
And so you didn't, I mean, you only show the congestion window, so you don't show the link utilization or the delay, but you don't utilize the buffer fully. You get an early notification, then you reduce the
yes.
That's what's happening.
Yes,
okay.
yes.
So if you read Man Jacobson's paper, then as long as you use slow start, you actually need 1 BDP of buffer just for slow start.
Yep.
And so for slow start, you should, and either you use a different startup scheme, or for slow start, you should actually have this buffer, because otherwise you block early, and then if you double your congestion window, you have to half afterwards in slow start. So that might help, but I'm not sure if it's the right solution, because if you actually have a large buffer, what you do is you induce a lot of congestion and a lot of delay. after your slow start.
Yes, so there is a little bit of delay. Of course, in our implementation, it's actually possible to set the beta ECN for a slow start and beta ECN for the congestion avoidance separately. So you could configure them separately. If you want to keep the beta 0.5 for the slow start, you can, in the implementation, you can still keep that. But we thought that actually it might contribute to the performance, because the number of steps that you're having is limited, because every round trip time you're going to get one CE marking. So you will eventually reach to the capacity line. You will eventually reduce the buffer. So, but this is of course separate from the rest. So this kind of side advantage. Next slide, please. So then we tested that for the short flows, and we looked at the flow completion time. And then with different beta values, you can see that, of course, in the beginning, you have the slow start, so you don't get much of the benefit for very short flows. But then as the flow size increases, actually using a higher beta gives you more benefit. So the y-axis shows the reduction in the flow completion time in percentage with both caudal and pi. And so the recommended value for beta, it's in the paper, but it's approximately around like 0.8 for a 0.85, depending on, you know, what policy you want to pick. But we had some recommendations on that, but I think that is something that we are going to arrive in the future of what exact beta value is the best for the ECN. So next slide, please. So basically we show that we can get a good utilization, and we can get a low latency without having to change anything except the sender and only a few lines of code. And that is only a parameter change, which allows to use a beta that is different than the standard beta only for ECN. So there is a technical report which is available online, and there's a draft which is an extremely short draft, which is because we wanted to keep up with the deadline, but we're going to add more text to it. So basically what I want to wrap up is that the entire thing here is complies with the RFC 3168. It's extremely easy to deploy because it requires no flag day. You can just turn it on right now, today. And it's only a minor sender-side modification. It already gives you a lot of benefit. You can get a significant throughput gain in the lightly multiplexed scenarios when you have the traffic on the access links. You can get the low latency using the current AQMs that are being shipped. And then you have no starvation of the standard TCP whatsoever. And then you have reasonable level of convergence and fairness with the recommended betas in the paper. Next slide, please. Okay, I'm done.
Nicolene again. Hi. Thank you for doing the analysis. What's your intention about the draft?
So we are trying to basically update the draft and basically submit it to the working group and ask for this parameter change to happen. So we're going to just take it up to the IETF.
Because I personally would say it doesn't violate the existing RFC. There's no change needed.
I think it does with regards to the 3168. So it requires a different response to ECN than to.
Okay. So Michael Wenzel, I'm a co-author of this. It was maybe not. I mean, it complies with the RFC in that it doesn't violate its rules, but it does update the RFC because the RFC says you should react in the same way as if you get a loss. So this updates a should.
That's a non-normative lower layer should, so it doesn't say anything.
That's even better.
Going first, and yeah, it's lowercase should.
So did you present this first time here, or have you talked about this in ICCRG or elsewhere? Like, I mean,
ICCRG.
Yeah, I see.
Yeah.
ICCRG.
Michael?
Did you have this in ICCRG earlier, or
No.
is this like the first time? Oh,
No.
Okay.
It's first time being presented anywhere, ever.
And then I have one more comment.
Yeah, please.
So, I mean, Cubic is using 0.7, I guess. I don't know. But you
Yes.
said actually it doesn't make a big difference if you say 0.8 or 0.7, right?
It actually does.
Okay.
If you look at the technical report.
So anyway, so from our measurements, we've seen that basically no Windows machines use ECN. So if anybody would ever use ECN at the moment, that's Linux, and they use Cubic. So I think it's already deployed.
Marshall Weitzel, the major difference here is that this is only doing this for ECN, right? So this is a big difference. You don't have the same backup factor for ECN. So the difference, if you take it with 0.8, right, with today's Cubic would be between 0.7 and 0.8. Well, that's about Cubic.
So one question from my end, I mean, updating Reno is one thing, but would the same thing be applicable to Cubic? But in particular, taking into account Mark Allman's comment that you don't do the fixed factor, but you multiply basically the one for loss. And what would it imply?
Yeah,
that
so the point is that
for Cubic, the ECN factor to something higher.
So with regards to that comment, multiplying by the loss factor, that basically somehow indicates that because the loss factor is relevant to the maximum available buffer size, whereas the ECN factor is relevant to your ECN marking threshold. And these two are not necessarily connected to each other. So you could have the ECN marking threshold somewhere that is, not at all a proportion of the maximum buffer size. So I think these are two completely distinct parameters.
No, I don't get that. But
as a percentage, like you can't.
Yeah, but at the end of the day, you can do exactly the same thing at the end of the day. It's just what the RFC tells you. At least that's my understanding how I read Mark Allman's comment. It's only about how you describe it. The end effect is exactly the same.
Okay, then, but then we could have like different percentages, and then say we go like with the 5% or 10%. But that becomes a bit more complicated because for every scenario we have to derive that percentage. But I understand the concept.
The key point, I think, but I might be wrong. Maybe I get it wrong. The key point is that, I mean, doing this for Reno is one thing, but the key question is the same idea applicable to other congestion controls? And my particular question is it applicable to Cubic, and would it have the benefit or not? Or is it maybe then in the Cubic case, maybe battery is too large, something like that?
Yeah, and so in the technical report, we have all the results for both Cubic and Neo Reno, and the betas that are recommended for Cubic and Neo Reno are slightly different. So in the tech report.
Yeah, but slightly, I mean, the key from a standardization perspective, the key is, do we have to issue yet another Reno update? Or can we do simply what Mark Allman suggests? Can we do Reno and others at the same time? And the latter, at least speaking as an individual, the latter would be much more interesting to me than updating Reno.
Okay.
That is my individual view.
Yeah, I agree.
Bob Briscoe, I didn't think it was a lowercase should. I'm just quoting from IETF93-TCPM-20150722-1300. The congestion control algorithms follow that the end system's capitals must be essentially the same as the congestion control response to a single drop packet. Essentially, I did wonder whether maybe 0.5 is essentially the same as 0.8.
Both are in the document. I suggest that this is an erratum, a technical erratum that needs to be filed against 3168. Yet another.
So, Richard Scheffenegger. So I believe one of the insights here, I believe, is that the marking threshold is in fact lower than what you have as a drop threshold, typically currently deployed AQMs, and therefore the effective buffer sizes in the buffers before you mark for ECN is smaller, and if you want to use that, utilize it more, or utilize it more evenly, you want to have a slightly higher factor by which you, slightly lower factor, by which you decrease.
Yeah.
So I believe the work itself is valuable, Mark Allman's comment is valuable, and I would like to see this both converge. Thank you.
Yeah, and my suggestion is that, I mean, parts of this seems to be like a perfect topic for ICCRG. And my suggestion from a procedural perspective is maybe in the next ICCRG meeting or something, you can discuss this. And once this has been sorted out, I mean, we can look at it again here in TCPM. So that would be my suggestion for this.
With ICCRG hat on, can you please repeat what exactly you want to see clarified?
Yeah, we want to understand whether it applies to cubic or other these kind of things.
The results were for cubic and Reno. So what exactly do you want to clarify? Everything was cubic and Reno. All results, everything.
But
the question is,
the question is whether Mark Allman's proposal, for example, is applicable or not. So that's the question.
What was the proposal?
On the mailing list.
To use a factor, to use a percentage factor.
And what factor? I mean, we will not discuss TCPM factor here.
But that is a very different, potentially a different thing to evaluate. So this is
yeah, sure. And that's why ICCRG.
So this is what you want to clarify. Okay.
And it's a research question, so. Coming up with a better factor is ICCRG.
All right, thanks. We need to move on. So then, Kostin.
Hey guys, this is a very simple change to TCP that's not done to improve TCP's performance. So it's a change from the long list of changes we've seen today. It's basically done to allow networks and possibly receivers to do more with information from the sender. Okay, and the idea is very simple: to put the number of backlog bytes that sit in the send buffer of TCP, to put it in every segment. Next. All right, so basically, if you look at network management, you can use netflow, sflow. So basically, you can get aggregate statistics per connection, or you can get some packet sampling, 1 in 100 or 1,000. But basically, if you want to do anything else, it gets really expensive. And one particular question you cannot answer is the following. Next. Is the connection limited by the network? Is the congestion window of this connection affecting its throughput or not, right? In other words, if I gave it more capacity somehow, would it be able to actually use it? Next. So the question we're asking is, what if we actually advertised the send buffer occupancy in segments? Next. So these are sequence numbers. Next. So send unacknowledged is basically the sequence number that we're waiting the first acknowledgement for. Next. This is basically what the application has last. So what the application has last written into the send buffer. Next. And send next is whenever we get an ACK, this is what we'll send next. So the part between send una and send next is our flight size, and the part between send next and write sec is the backload information. Next. So this is what we're trying to advertise. Next. So okay, so what happens? Just go next. So this is a plot of the send buffer information against time. So you have time on the x-axis, you have send buffer information kilobytes on the y-axis. This is a disk transfer. It's an rsync between two machines connected via a gigabit interface, and it's a fairly slow hard drive. So what happens is you basically have a very small burst in the beginning in the send buffer information, but it's mostly zero. And this is because the application is bound by the I/O, right? So it just cannot read the data fast enough from the disk, and the network is underutilized. Next. So in contrast, this is an iPerf. Okay, so this is how an iPerf looks if you look at the send buffer information. So basically, it opens up in the beginning, and then it sort of stabilizes around 160 kilobytes. This is a very low RTT, so it's like a 0.1 millisecond RTT. Next. So okay, so what do we use this for? So the first question is, in many cases when network operators try to figure out is my network running correctly, they typically look for loss rate and say, well, typically if I have high loss rate somewhere, that means I have a lot of congestion, and maybe I need to upgrade my network. And that actually is not the case in data centers. Next. So if you have many-to-one traffic patterns like incast, where for instance, a front end will farm out queries to a lot of workers, and these reply more or less at the same time with more data. A lot of that data will be lost. Next. So we actually ran this on EC2. So we had one receiver and 99 synchronized senders, and we actually measured. We varied the amount of bytes sent by each sender to the receiver, and we basically measured the loss rate, and we also measured the average send buffer occupancy as advertised by the sender. Next. So okay, so what we're varying here is how much each sender sends to the receiver, and on the y-axis we're measuring loss ratio. So what percentage of packets were lost in this experiment. So as you see, it's fairly high, so it can be as high as 7%, depending on how much you send, and then it varies around 2, 3, 4, 5%. Okay, and on this y2 axis, I have the send buffer information that's included in those same packets sent by those senders. And as you see, the send buffer information in this particular case is actually fairly low. We're talking like 50 kilobytes, and only in this case where the response size is fairly large. So basically, if you had information, if you as a network could see that, for instance, in this particular case, there is no send buffer, there's no backlog information, you know for sure this is incast, right? This is just because the senders got synchronized and they sent, and you had this problem. Next. So another example is helping data center applications. So typically, for instance, when you're on MapReduce, you might have a map job that is struggling, right? So it's falling behind all of the other map jobs in its generation. This is called a straggler. So at this point, typically the scheduler will ask, well, this is slow. Should I just start it and just kill it and start it again, or actually just start another one in parallel, hoping it's going to finish earlier? And it turns out that in many cases, if you do that, the outcome will be worse. Go. So for instance, next. So for instance, if just this link is very bad, it's probably a good idea to actually start the map job on another server, because maybe the link of that server is better and you actually finish earlier. But if the hard drive is the problem, then probably it's not a good idea to start another map job, because there's high likelihood that it's going to use the same replica to actually download that data, and you're obviously just adding gasoline to the fire in this particular case. And you can actually use the send buffer information of this TCP connection to figure out which case you're in. So if the send buffer information tells you that, look, this application is not backlogged at all, that means, for sure this connection is not a problem, right? Next. Okay, so another example is mobile performance. So obviously everyone has Wi-Fi and 3G. We saw people are actually deploying multipath TCP. So that means users who like to stay on Wi-Fi, but in some cases go on 3G or LTE when they don't have enough performance. Of course, the question is, how do you tell when you don't have enough performance? So typically, the current policy is you stay on Wi-Fi until it completely breaks. But let's say I'm listening to radio, or I'm watching some video, right? In that particular case, I may be getting some rate, but it's not enough to actually keep the application going. Next. So what you can do here is, for instance, at the receiver, you can monitor the send buffer information. You know you're running some critical application, critical in terms of for user satisfaction. So basically, when you actually see a send buffer that persists, what you can do is actually turn on 3G or LTE or whatever you have on the phone, and that basically will actually give you enough capacity to run your application. So this is an experiment we did with some desktops, so it's just for illustrative purposes. So our final use case is trying to understand, from the network operator's point of view, trying to understand how well a connection is doing. So trying to figure out, for instance, using S-flow, using sampled packets, trying to understand how many losses that connection has experienced. Next. The observation is the following. Typically, the size of the TCP send buffer is fixed after a few RTT. So you can consider this whole thing as a constant. Now, the congestion window will open and close depending on what's happening in the network, and the send buffer will actually vary in the opposite direction, because as the congestion window is increasing, the send buffer is decreasing and the opposite. So go next. So if the actual congestion window looks like this, send buffer information looks like, go next, looks like this, for instance. And this is an exponential moving average of the send buffer information, because there's a lot of variation because of the scheduling in the operating system. Okay. So what happens is, you can see that whenever you get a drop here, you'll also get a change in the direction of the send buffer, right? So if you actually sample, for instance, so go next. So you can actually look at all of these peaks and actually count the number of drops in the flow without actually seeing the congestion window. And if you actually sample 1 in 100, so there was no sampling here, so just you could see the send buffer in every packet. But if you sample 1 in 100, next, this is the signal you get, right? So again, a moving average over the send buffer information. Again, you see inflection points in most of the places where the original flow got dropped, right? So this is like second order information you're getting. This is not the main purpose of this, but it does allow you to get in a completely passive way to get a sort of an idea of why a connection or what the performance problems were with a particular connection. All right, so I'm done with the use cases part. So this is the more IETF style part, which is how do we actually get this in TCP. Next. So this is not going to go down well, right? So people don't want new TCP options. There's no space. Joe Touch will jump on me if you were here. So we don't want to do this. Next. So what we're proposing is actually this is a sender-only change, right? The receiver doesn't need to be changed. Basically, if the receiver or the network they know the standard, then they can use the information. Otherwise, we would like to have the encoding of the send buffer information done in such a way that it doesn't affect receivers that have not been modified. Okay. So the trick is to ensure legacy boxes are not affected. Okay. Next. So basically, we're not negotiating send buffer information. If the sender wants to encode this, it will basically just have like a syscontrol or something, and from that point on, it's going to be encoded, and the hope is that it doesn't affect anyone else. So whoever can decode it can use it. Otherwise, Next. Now, the question is, how do you encode this? Like, how do you actually put it in the data segment? And the obvious solution is a TCP option. That's the simplest one. Next. So clearly, it's not ideal because it adds overhead, and ideally, you want this to be always on. We don't have much space in the options field, so it's not an ideal solution. Next. But it should work just fine. So basically, you don't negotiate anything in the three-way handshake, but then just start putting the options in. So our previous tests that we had published a while ago and we used when designing MPTCP show us that the middle boxes will either allow these options to get through or just scrub them, right? They will not drop the packet, which is perfectly fine. So we will put the information in. Maybe it gets there, maybe it doesn't. Whoever wants to use it can use it, okay? And we haven't checked this, but probably receiver stacks just ignore options they don't know. So again, this is like a very simple change, but we have to check it. So this is sort of the simple option, but it does use option space. Next. Now, the more controversial option is probably going to generate some discussion. It's based on this observation that the TCP data stream is typically unidirectional. So if data is flowing from left to right, the X are going from right to left. Next. What's happening is the valid or the actual fields that carry useful information are shown in black here, right? So in particular, in this direction, the acknowledgement number and the receive window field, they actually carry no new information, right? In the opposite direction, obviously the ACK and receive window field are carrying a lot of information, but the sequence and data are not useful. So basically what we're trying to say is, next, we're trying to say, well, you saw that coming, didn't you? Okay, so we're trying to say, why don't we just scavenge these 6 bits we have, the 6 bytes we have here, and just send buffer information there. So yeah, just put the gloves on. Next, I have 2 more slides, and then you can jump. Yeah. And it's not fair to Stuart. He queued up like from the beginning of the talk. I'm sure he has a lot of. Okay, so there's 2 cases where you can do this. I mean, the first one is, well, you want to do this in data centers. That's fairly simple. Basically, you just take one of the reserved flags, define it as send buffer advertising. You basically say whenever this is on, you just make sure that the ACK flag is off. So either the ACK flag or the send buffer flag are on or off, and then you just encode it in the ACK field, and you're done. So in data centers, it's going to be just fine. So it's probably not a big deal. Next. Now, in the internet, this is even more controversial than that. So we cannot really define a new flag. It just doesn't go through the internet. So basically, what we do is we disable the ACK flag. Okay, just to tell the receiver, the information is not valid, so don't use it. We encode the value in the ACK field, so we have 4 bytes for this, and we age MAC it in the receive window field, right? So whoever knows the standard has to actually check the age MAC of the ACK field to tell whether this is a good value or not. All right, next. Right, so so we believe that having this information can prove very useful in a lot of situations. And the trick to do this would be to actually have it on more or less all the time. So that's why it's actually nice to have it without overhead. So it's like zero cost. Okay. So we've got a workshop paper on this, and there's a draft that didn't make it to the cutoff. So it's just been submitted a couple of days ago, but you can have a look. And with that, questions.
Just a quick note, if you haven't sent blue sheets, then please do so.
We have one more item on the agenda, which is my colleague from Apple talking about how we just turned on ECN for every Mac and iOS device on the internet. So I think people in the room will want to hear that, so I'll try to keep this comment really short. Regardless of how you encode it, at least on Apple's operating system, we just made this irrelevant because we don't have a backlog anymore. What we observed is that the backlog in the kernel is just, it's more buffer bloat. Particularly for anything real-time like screen sharing, you generate frames, they sit in the kernel getting moldy for a few seconds before they even go out on the wire. And there's no reason that screen sharing benefits from having its frames all mature in oak casks before they go out. Right. So we said, well, and RAM is cheap, right? The kernel can buffer almost an unlimited amount of data. So we just said, let's not do that anymore. So K-event only reports the socket writable when the backlog goes away. So there, in fact, is no backlog for you to measure. And that affects so many things like you type ls in a big directory by mistake, and it's scrolling by, and you hit Control-C, 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 and it won't stop because you've got a megabyte of text sitting in the sender's kernel that it doesn't have any way to pull back, and it just goes and goes and goes. So we made a whole bunch of stuff much more responsive. What your real test is the sender is saying, I could go faster if you let me, which is really a binary flag, right? It either can go faster, because if it can deliver 11 megabits and the service rate is 10 megabits, then the queue will grow until the kernel stops it growing. And if it can't keep up, so really the queue is a binary. It's either empty or not empty. And we just made it empty, and we only tell the application to deliver data when we're actually ready to send it.
That's cool, yeah.
And it's in Linux too.
Yeah, I mean, I would bet you cannot fill 10 gig without having some buffering in the kernel, but we can take it offline. A few hundred kilobytes. It doesn't have to be much, yeah.
Matt Mathis, I believe that your algorithm also conflates network bottlenecks with receiver bottlenecks. It's really telling only when the sender's ahead.
So you have to look at the receive window also to get the full picture.
The other thing is in RFC 4898, which is the TCP extended instrumentation MIB, there is 3 timers that accumulate basically the reason why you exited from TCP send. And those timers tell you what you're waiting for in a fairly authentic way. Now, this is only a sender-side instrumentation. It's meant to be read from a diagnostic implementation, and it hasn't actually been fielded.
So we should cut the lines, by the way. So if you can make quick points, Mirja.
It's a different, a different solution. That's a more robust solution, and that's.
But you still have to signal it, yeah, somehow.
If you want to see it on the wire, but it's meant to be accessed through an SNMP type style access. It's a side channel.
So what if it's not on the same network? I mean, this is like.
Yeah. So if you turn off.
What about if we move the next talk to ICCRG, which is next?
No, I think this will be quick. If you turn off the ACK bit, doesn't the other end throw the packet away if it doesn't know about your?
We have to see that. Yeah.
No,
I mean,
and let's hear the next talk.
Just a very quick comment. I think this one flag which says I'm application limited or not would be useful for not only TCP but for general purposes.
Yeah.
Thanks. All right. Cool. Thanks, Kristen.
Hi. So I'm David Skenazy from Apple. So first of all, thanks to the chairs for letting me jump into the agenda last minute like this. But I just got a few hours ago approval from my management to share some ECN numbers from Apple. I don't have any slides either, but I just have some numbers, and I thought a few people in here would be interested. So In case you didn't know, Apple has enabled ECN by default in the seeds of iOS 9 and OS 10 Capitan. So we started seeding those a few weeks ago, and just all of them are doing ECN. And the universe is still here. We have, as far as I know, no support calls saying ECN set my house on fire. So this is first bit of information, and that's kind of cool. So to give you a little bit of background, why do we do this? Our goal isn't to have today improve the performance of TCP, because when I run through numbers, turning it on doesn't improve the performance of TCP today because the routers don't support it yet. What our goal is to make sure that the internet is ready for ECN, supports it properly, and second, to give strong incentive to vendors or to network operators, to implement AQM that supports ECN. Because today, if you go to one of them and say you should be doing QM and ECN, they'll tell you, but no one does ECN. Why do I care? I'm going to work on some other technology instead. This is a higher priority. If you tell them that quite a big number of his clients want ECN and they would make their connections better, then they'll listen. So that's what we're trying to achieve with this. First of all, we did some testing in the lab and reproduced the data from the 2015 ECN paper by Brian Trammell, Amir Kluwind, and others that I know are here. We saw 59% of the Alexa 1 million. So the trend is still going up in terms of server adoption. That is still good as well. But the really interesting stuff that we saw is the data from these betas, because we have, I don't know the exact number, but we have a lot of people running them. And by the way, they're available for free at beta.apple.com, so feel free to try them out. If you that way on iOS 9, it'll do ECN and Mac as well, but that you can also enable it with the sysctl on any version that's relatively recent. So what did we see? We saw that on iOS, 23% of TCP connections successfully negotiated ECN end-to-end. So one of the reasons I think I haven't gone digging much further yet, but that there's 59% of servers that support it in the Alexa 1 million, but it's only this many collections, is that all the major servers don't necessarily support it yet. But also, and in Mac OS, that's 32% of connections that were successfully negotiated with ECN. Regarding the number of congestion experience markings, yes?
Clarification question. Yeah. These percentages are percentages of what?
Oh, sorry, of TCP connections.
Made by
those devices.
Users.
Oh, no, yeah, all these are users and yeah.
Excellent.
In the wide area, all over, everywhere. Every continent.
Excellent, thank you.
Yeah. And in terms of EC, so congestion experience markings, well, it confirms what we thought. No one marks right now. No one supports this. iOS, 0.08% of markings. macOS, 0.01. At this point, we don't even know if they're actual markings or just random bits. But there's room to improve. And for the EC markings, same order of magnitude. That could have... And we also did some field testing with on the order of 30 carriers, where we went on with iPhones on their networks and tested, saw what happened. One of them was really interesting. As soon as you start marking your traffic as ECN capable, they just go nuts. They reorder every single TCP packet they see, and we cannot possibly comprehend what they're doing, because it's not like the ones that are marked as congestion experience get on a different path. It's just carnage, but we'll have to talk with them and see what's going on. The one worrisome, yes.
I just wanted to clarify that what you were talking about was only one carrier, right?
Yes, cell phone carrier.
And the thing that was interesting is the reordering that seemed to be induced by having by having ECT marks. Didn't itself actually hurt the performance. TCP coped with that really well. The only reason we noticed it is because it had this side effect that it interfered with the send window auto-tuning algorithm, which starts at 64K and then grows up to a megabyte. but that's disabled when there's reordering. So we ended up being inadvertently sender-side limited because we were not doing, or it might be receiver, but the window auto-tuning was disabled because of the reordering, and then so it was sort of a third-order effect of ECN ended up making us slow.
It was sender-side. In this case, it was an FTP upload test to measure throughput.
Was this using ECT0 and ECT1?
Just ECT0.
Okay.
And however, the one more worrisome data point that I think is the most valuable from all this is that roughly half of these carriers clear the toss byte. And they let the ECWR go through, so your TCP thinks that ECN is going through fine, and then if you watermark, it would be dropped. So that's unfortunate. That's something we need to address.
Hi, Aaron Falk. If I remember the hiccups paper correctly, there was a mode where interference by middle boxes where the client thought he was doing ECN and the server thought he wasn't, and neither was able to become aware that the other one was in a different state. Were you aware of that case? When you say you're able to negotiate ECN, are you getting? You check both sides. You're working with a server that you own the server.
We own the server.
So Richard Scheffenegger, clarification question. So these were 6 carriers in the United States where you did active measurements, basically.
There was on the order of 30 carriers worldwide.
Okay, but these were active measurements made by you, and you induced the CE marks, the ECT1 marks, whatever.
Correct.
Okay. There was one one word of advice by Brian: look out for stuff that you wouldn't dream of.
I mean, I heard a really good quote about there being only 4 bits and somehow more than 16 ways to get it wrong.
Definitely.
The point of us announcing this at the developer conference and the point of David being here is that we have the betas available for anybody to download, and we want to encourage as many people as possible to do that, because the broader testing we get, the more information we have to make an informed decision.
And so that's all I had for data. And just to add to that, there's a lot of work going between here, ICCIG, TCP Progress, over stuff that needs ECN. And we need to get the word out that people should not be clearing the toss byte. It's pretty common. And so we should all be testing this. And if you notice it on your network at home or something, call customer support. Tell them it's bad. All right. Any last questions?
Just one quick comment from me as chair. I mean, we have very fast scribes here, but it still would make sense if you could post those numbers somewhere, because we had a lot of clarification questions.
Yes, I'll try to write this up.
Either TCPM or I guess there are many. It doesn't matter that much which mailing list it is or which internet draft, but I think writing that up would be TCPM would be perfectly fine.
So Richard again, last thing. So what I noted was basically that there's a lot of gear out there that takes the toss byte that you send out with the SYN and then rewrites that toss byte during the entire session. So if you send out a SYN with CE marked, your entire flow will be CE marked.
We haven't tested that in particular, but yeah, a lot of weird stuff happens.
Okay, thanks.
Thank you.
Very interesting. And thanks for participating. It was a very productive meeting, so see you next time. Thank you.